So I hope that you recognizing this problem so we can do it together. Oh, we were not in 5.6. That's what I thought because it's open in 5.6. I'll give you exercise 5 today for quiz, no worries. Let me see, because I was, I guess, last week planning something and then we got the section 5.5. Okay, so section 5.5 is probably the most popular section here because it approximates normal distributions by that standard normal. And exercise 9 here is dealing with the exercise where I asked you to find this z-score, right? So for problem number 9, we're using a formula that deals with z-scores, which is x subtract exercise 9. I asked you, so I'm talking right now, which was the quiz question, x minus mean divided by a standard deviation over square root of n. So for a quiz, I asked you to use this formula for a data set here that had mean of 14.4 for the population mean, with the standard deviation here given as a 1. And I believe I asked you for a sample size equal to 3. Yes, thank you. Thank you. So sample size was 3 rather than other number. So the question was only to use your calculators carefully and to give me that value of z-score. And again, x was the same, it was 16, right? So 16 we put in for letter x, then population mean mu is equal to 14.4. And standard deviation of 1 is divided by square root extracted from number 3. So this way we have a start, and then we used parentheses around our numerator as well as around our denominator. So the calculator would be utilized to do this little calculation. So let me get that calculator. I don't see it here. Let me open it up. Scientific calculator. So you just start typing and it appears ready for you right away. So you just select that Desmos. That's the one that I would highly recommend. So 16 minus 14.4 in the parentheses will be divided by, in the parentheses, 1 over square root of 3. So this is it. That's my z, which is 277 and so forth. So looks like 77, right? So this is my value of z, which I have here. And some people put 1 or 2, 2, whatever. Yeah, you can just use more digits. We usually just round it to nearest hundreds, and that's good enough. So that's our last time quiz. Of course, the question is, what is this for? So let me actually select an exercise to better refresh your memories and also to see where we can apply all of these ideas. So how about problem number 11? Amounts of Coke in a can. So we know that when you purchase the can of Coke, it says there are 12 ounces in it. So they decided to double check if that's correct or not. So I'm looking at exercise 11 that deals with the average or mean equal to 12 ounce. And also the standard deviation, which is 0.11. So that's a sigma, right? 0.11. Also, question deals with sample size 36. So it's n, right? Sample size is always n. And part A here wonders about finding probability that the amount is at least 1219. So at least means greater than or equal to, isn't it? Remember, we worked with this at least in previous chapters a lot. So at least means not less. More is fine, but less is not going to fit with at least. And actually, if you have 1219, maybe that's a type of a barrier. So if you pour more than that, then there might be some issue with a kin. So let us see what's the chance that this is going to happen. And we going to use favorite normal distribution with mean given as 12. Now we also have a probability equation attached. So 1219 is bigger than 12. So you got this border, and the question is, what's the probability or area of this particular region? And to find that probability, I'm going for the area from that corresponding z-square all the way to the right. So I need to go to the corresponding z-square and see what's the area of that region to the right from my particular z-square. So looks like we're now going to use the formula that I just utilized for the previous example. So to find the z-square, I need to divide the difference of that x, which is 1219, with a mean for population, mu, which is 12. So I divide this by standard deviation 0.11 that we put over square root from sample size, which is square root from number 36. And we use parentheses around numerator as well as around denominator. So that's how we get our z. So let us put this all in the calculator. And looks like analogous expression will be for us to calculate. Please notice that in this chapters, you will have pretty much same fractions that you need to carefully put in your calculators. So if you feel good about the calculator that you're using, that's important. If not, advice is do the same problem again sometime tomorrow and try to produce exact same expression. And now we get z-square, which is 10.363636. So we usually round this to nearest hundreds, right? So the z-square of 1036 will be here. And this z-square, now I need to locate in my tables. I need to open tables as well. So Triola tables. So here's the choice, Triola tables. So we go for the 10.36 and the standard normal distribution, which is very big z-square. So go to the positive page of positive z-scores, which is page 6. And I noticed that 3.5 or larger is all I can do here because there is no bigger numbers than 3.5, but that's okay because they tell us that area from that z-score to the left will be a point and a bunch of these nines, right? So we always get areas from z-score all the way to the left, and they, of course, mention it up here, so they make sure that we know what we found. So from the left side, and I need on the other side, I need area which is called a complement, right? So we subtract from 1 as usual, and this gives us answer 0.0001. This is extremely small number, so the probability that this is going to happen is very, very low. No chance, in other words, it's less than 1%. It's way, way less than 1%. So there is no way this is going to happen, which tells us, in a case, if it still does, if it still happens, well, then something is wrong. Maybe adjustment is needed to this equipment that fills coke into those cans. And that's exactly what they're asking here in the part B. So they say, is it mean that it's not 12 ounce? Well, looks like, yes, they give people more coke. So are they being cheated? Well, I don't know if they get more than they deserve. They probably not, but who knows what might happen with those cans if you try to fill it with, not with 12 ounce, but with 13 ounce or with 20 ounce, they're probably going to break those cans, right? So that could be not a very good idea to do. So the point is, if you sell in 12 ounce, then you should adjust your equipment and don't give average more than 12 of these ounce. So looks like exercise that any technologist that works on some production could face, not just with a coke, just about with any liquid filled into cans or anywhere else. So it is really very applicable case for real life situations. So idea is when you do these problems here, you actually do pretty much same thing. All you do is you get this z-score conversion formula, and you actually use tables. And that's actually what we also do in the next section, in section 5.6, which is a special section that tells us that we can use normal distributions pretty much everywhere, not just in the case of normal situation, but in the case of binomial distribution. Remember, we had previous chapter 5 that was working with binomial distribution, and it was working with those two formulas for mean and for standard deviation. In the case we were not given mean and standard deviation. And that's actually what they're using in here. I think it's a pretty neat application of how you can utilize the normal distribution pretty much anywhere, because then you can use those little tables and get probabilities calculated. So let me try the problem that one can see somewhere in, let's say, nursery, like exercise number 13, that talks about the probability of getting more than 55 girls. So I'm looking at the exercise 13. This is section 5.6. I went to page 508, next section, to show you that we're not going to do much different type of calculations to find probabilities when not everything is given to us. So in this question, they say, what about probability that more than 55 girls, means X is greater than 55, right? More means greater. Will appear when number of birth is exactly 100. So they say that we assume that probability for baby girl or for baby boy is the same, it's 0.5. So they're so-called equally likely. The chances are equal, they say, for baby to be boy or a girl. So we put 50% for each or 0.5, 50-50, right? So P is a chance that that's a girl and the complement is Q, which is a boy. So looks like standard start. So now they want to find the probability that there are more than 55 girls. So it looks like we expect half, like 50, right? So we have 100 babies, half of them will be 50. And now, what's the chances that there will be more than 55? Well, turns out that I don't have mean and I don't have a standard deviation here. And I need to recall that we used these two formulas to calculate mean and standard deviation when we worked with the binomial distribution. So when we worked with binomial distribution in chapter 5, we utilized these formulas to get mean and standard deviation. So it turns out that in this section, they added these two formulas to the story that we already saw previously, because with these two formulas, now we can approximate what's happening here with a normal distribution. So what does this mean? Well, I saw a nice picture somewhere in the previous section, so let me show you what is going on intuitively. How do we do this approximation? Well, notice that this binomial distribution can be approximated by our favorite normal distribution. But you need to have enough elements in your sample. So people say usually if your sample is big enough, like we have here 100, it's more than 30 elements, then we can definitely use the approximation by normal distribution. So it should be just large enough sample size. And that's the idea. So what I can do is approximate this type of distribution they have in the picture with normal distribution, and the number they have here for us is 55. So let's say if it's a 55, next column, notice just like on the picture, we deal only with the whole numbers because we're actually looking at the birth of the baby. So it could be either 55 or 56 or 57 or more or 54. So it makes no sense to talk about fractional pieces. So we can only go with greater than 55. So 56 or 57 or 58 or etc. all the way to the right. And this means that we can go with the 0.5 increments. So in this section, they give us extra piece of information that talks about using the so-called 0.5 increments. So we have the region that will actually start in between of 50 5 and 56. And that's definition they provide us with here. It's so-called continuity correction. That's the only new thing that we observing in here. So let me get to this definition in the section 5.6, continuity correction. So it's right there in this blue box. So that's what they're actually talking about here. So if I'm looking at this blue box, let me clean this mess a little bit around it. So in this definition, they say if you approximate your distribution by normal, then you need to have this 0.5 either added or subtracted to produce the approximation. And that's exactly what we're doing. So we're actually not taking this distribution, but we're thinking about some normal distribution here, which is approximately the same. And in order to approximate it, we must see the border. So the border where we start, and we start according to the question of this exercise at the x greater than 55. So greater than 55 means it could be either 56 or 57 or 58 or everything to the right. So we have a border in between of 55 and 56. So we say that this is approximately equal to probability that x is greater than 55.5 in between of 55 and 56. And again, the reason is definition that they give it to us here in the section. So because of we are approximating, because we're not given mean and standard deviation, so we need to do this approximation. Because once you decided on that approximation, then right away we get a z-score story and we get our answer calculated. So I just need to get a z that corresponds to this particular value of x. And for the z-score, here we use formula x minus mean over standard deviation. We actually don't divide by square root of n because we have n already inside the square root here in the standard deviation. So x is 55.5, so I use that number that I produced. And instead of mean, I already know the formula, which is n times p, so I just need to put numbers 100 multiplied by 0.5. Please notice, I don't calculate this separately. I know it's 50, but in some problems, you better let calculator do the whole thing for you, because sometimes you might get pretty rough approximations and that's not going to be very close. So sigma is a square root npq, so it's 100 for n, p is 0.5, and q is also 0.5. So we have this numbers here. And I just need to put all that in my calculator. As usual, I need some parentheses here. You don't have to put parentheses around your denominator because it's going to be just a single square root. So I'm going to just go with this numerator 55.5 minus 100 multiplied by 0.5 parentheses, and then divide this by square root extracted from 100 times 0.5 times another 0.5, just like that. So we've got some particular z-score, which is 1.1, and we know how to finish up with it, don't we? We need to find the region that corresponds to the one highlighted. and that's a region to the right. So all I need is tables, and this tables is my 1.1 for z-score will give us the answer. So notice that 1.1 is here, and since there are no hundreds, I have to use first column, right? Because it's like 1.10. So here's the probability, as usual, on the intersection of these. So 8643, right? 8643 is not the answer yet, because my answer will be on the other side, just like in the previous exercise. When 8643, I take a complement, the other side, right? So the key part is that this is called distribution. So the whole area is always equal to 1. And that's why we subtract from 1 and we get our answer as 1357, right? 1, 3, and then 5, and then 7. So what I did, I incorporated in this section formulas from chapter 5, that NP for mean and standard deviation, that square root, into the exercise. So we could actually calculate probability if we don't have mean and a standard deviation. So if you don't have your standard deviation and mean, well, then you can use these formulas and get the results. So let me take a look at this new part of the story, this so-called continuity correction that we utilize to approximate our distribution. So that's really a key part. So I'd like to do some problems here and then have you try to do one where they don't give you enough information. All they want is just to approximate. So we should get used to this new step in approximating your distributions by norm. So like in exercise number 1. So now we're in the section 5.6. Problem number 1 on page 308, you can see it circled here, says, what's the probability that more than 15 people, X is greater than 15? So that's their question. X is more than 15. So how to do the approximation of this with normal distribution? So just like in the previous example, I'm gonna make a picture analogous to the one that I had there on the right. Now I care about 15 here, right? So next is 16 and previous is 14. So the idea is to get that 0.5, right? The approximation always has 0.5. So we need to make a picture to see where we are here. And turns out if you're greater than 15, it means you could be equal to 16 or 17 or 18 or 19. So anything to the right from number 15, it's in the greater side, which means that we're having a border right here, right? You see where this highlighted region is. It's in between of 15 and 16. So we say it's a 15.5. And this is my approximation. So it'd be X is greater than 15.5. So that's the only thing they ask in this exercise, because all they want is so-called approximation. So for this entire group of exercises, they ask just to get that continuity correction. And that's what we just did. So I'd like to practice with this because it looks like this is interesting and a little bit different, right, with what we did before. So let me do another problem here. Number 2 exercise. So we start to see that these are analogous questions to each other. So they say at least 24 students. So in exercise number 2, we're talking about probability of at least 24 students, means X is, remember, at least greater than or equal to. We already saw this today. It is a very popular statement in statistics, the word at least, right? It's always greater than or equal. So look at the picture that I'm making. It's exactly the same picture, but now 24. Since we're comparing it with 24, so that'd be our number in the center. 23 is a little bit less than 25, follows 24, right? So now I need to make a highlighted region that corresponds to equal to 24. So I take this rectangle entirely. And then again, greater. So I go to the right. So I just made greater than or equal. So I have the 24 included because of equal sign. So the borderline is in between 23 and 24, right? So it's 23.5. So it's always with 0.5. So when I approximate this, I say X is greater than or equal to 23.5. This is my approximation. So looks like all we care about is where is the border? That's really what we need. So let me do problem number 3, and then maybe you can do number 4 as a quiz for today. So later exercises after 9, they have more steps. So that's why I'm gonna continue talking about this section next time, of course, because we need more. Definitely we need more problems to be done. But I think if you start to see how to do this continuity correction, then that's really all you need. So in exercise 3, they say fewer than 100 passengers. Maybe I'm gonna ask you number 5, because this 4 is something that I should do probably next time. Maybe I'll ask you for quiz number 5, because 4 is a little bit different. So 3 says probability that fewer, that means less, right? Less than 100 passengers in the next commercial flight. So now we're going in the other direction. So again, I get these 3 boxes. You can put more if you want, but you really need to surround 100, right? Fewer than 100 with 2 numbers such as 99 and 101. So once you surround them, then you need to see what means less than 100. Well, it means 99 or 98 or everything to the left, right? So less than 100. We don't include 100. We just go with in between of 99 and 100. So this be a border where the pink region starts, right? So it's 99 and a half. It's in between of 99 and 100. So we got P is X smaller than 99.5. So continuity correction always needs 0.5. So please do a continuity correction for exercise number 5 for me for a quiz. I can help you get started. So the question is asking about probability that no more is not allowed, which means that less than or equal to 4 is what we need to approximate. So approximate this probability. So all you have to do is write with 0.5 increment, and that's all we need for that little quiz. So I'm going to stop to record. As usual, if you want to